Hi, seventh graders. Today we are going to talk about how to apply some percent to solve some application problems that involve percentages. So we're going to talk about a few different terms that we're going to be looking at or we might see today, and then we'll go ahead and start solving some problems. So first of all, taxes. A tax would be something like if you go to Target and you see an item that costs $5, when you go to pay for it, it's going to end up costing you a little bit more than $5 because there's a sales tax added on top of it. So sales tax is a percentage of whatever the price was. And so that gets added on to the original price. So when you talk about a tax, your price is increasing, okay? We have tip, all right? So when you are out to eat with your family or friends and you're at a restaurant, you have a waiter or waitress that, asks what you want. They take your order, they bring you your food, they might ask you if you need any refills. And so typically you would leave a tip on top of whatever your bill is. And so what that means is, let's say I get a bill for my total is $20. Now I'm going to leave a tip on top of that $20. And so that's usually a percentage of the amount that your bill was. So a tip is also going to increase your price, okay? A discount, if you're at the store and something is discounted, that means your price is lowering. If something is on sale, your price is lowered. And then markup would be like if when you go to a store, that store actually had to pay to somebody or some company to have the items in their store. So they bought things to have in their store. And so if, let's say, Target buys a shirt from some company for $10, they're not going to turn around and sell it for $10. They're going to mark up the price by a certain percentage so that they can make a profit. So a markup is going to be an increase. So we are going to look at some problems that involve all of these things: taxes, tips, discounts, markups, and how we can solve these. So these problems are still going to be based off of finding percent of a number. And so when we find percent of a number, you have a few different options. That's where you could either use your percent proportion, so your part over your whole equals the percent over 100. You could use your percent equation, which is where, to solve for the part, you take that percent as a decimal and multiply it times the whole. Or this is where you might be able to apply percent shortcuts on some of these too. So the first step is going to involve some approach, like these three ideas, and then there's going to be a second step involved too. So number one, a pair of socks costs $6.95, but they are on sale for 20% off. What is the sale price? So the very first thing we want to do, we have a percent, okay, and we have how much the original price was. And so the first thing that we need to do is we need to figure out 20% of $6.95. So this is the first problem we're doing. This is where you might be able to use your percent shortcuts if you wanted to. The percent shortcut would at least be a good way to estimate if you wanted to do some rounding, but for the purpose of this, we're gonna do the exact math. So whether you use a percent shortcut, percent proportion or the percent equation, you need to figure out 20% of $6.95. So the percent proportion, your setup would look something like that. If you used the percent equation, that would be turning 20% into a decimal and multiplying it times $6.95. However you do it, you need to figure out that 20%. So 20% of $6.95 ends up being $1.39. So we're not done yet, but that's representing the amount you're getting off the price. So then our second step is if the original price was $6.95 and we're getting $1.39 off, we need to subtract. That means our price is lowering, okay? And so we need to subtract that, and we end up getting a total sale price of $5.56. So these are going to be two-step problems. You're looking for that percent of the number first, and then after that, adding or subtracting from there, depending on what the problem is. So number 2 is store purchases homemade cookies for $1 each. The percent markup is 15%. How much do they sell each cookie for? So our first step is to figure out 15% of $1. So again, either using a percent shortcut, using the percent proportion, or using the percent equation. So when you figure out 15% of $1, using whatever approach you want, 15% of 1 ends up being 15 cents. Okay, so then what we need to do is this is a markup. So remember, a markup increases our price. So that means for our second step, the store purchased the cookies for $1, then marks them up by that 15 cents. So now the selling price is $1.15. So you're looking for some of those keywords for if it's a tax, if it's a tip, if it's a markup, if it's a discount. That helps you know if you're adding or subtracting that amount. Number 3, if you purchase a dozen bagels, you save 10%. If a dozen bagels originally cost $11.50, what is the sales price? So first we need to figure out 10% of $11.50. And so when we figure out 10% of $11.50, this might be a good one to use your percent shortcut on. I know I can move my decimal over one place and get $1.15. So then I'm going to go back and read this. So it's saying I'm going to save 10%. Okay, so if I'm saving 10%, that means I'm getting 10% off. So now I want to do $11.50 minus the $1.15. And I'll figure out that I'm going to be able to buy those bagels for $10.35. Number 4, if a sweatshirt is on sale for 35% and now costs $52, what was the original price? This one's a little bit trickier because we're looking for the original price. We have to kind of work backwards a little bit. So if it's on sale for 35% off and now costs $52, we almost need to think, okay, well, 35% off leaves us paying how much of the price? So if we're getting 35% off, that means what we are paying is we're paying 65% of the original price. So the $52 that we're paying is 65% of something, and then we can use this proportion to help us solve. And again, you could set this up in the percent equation too. And so to solve that, I'm going to use cross products. So 52 times 100 has to equal same thing as 65x, and divide by 65. And then I will figure out that my original price was $80. Number 5, Carmen purchases a new laptop. It's on sale for 12% off. If it originally cost $1,200, what is the sale price? So we're figuring out 12% of $1,200. You could use your percent equation. You could combine percent shortcuts. You could use the percent proportion. When we solve that, you should end up finding out that 12% is $144. That tells us we're getting $144 off because it's on sale. So then now I need to subtract that from my original price to figure out how much, what the sale price is. So that leaves me with $1,056. Number 6, the museum gift shop buys bug collecting kits for $8 each. They mark them up 75%. So my first, the first thing I need to do here is figure out 75% of 8. You could do 0.75 times 8. You could set up a proportion. You could use and combine some percent shortcuts, but 75% of 8 is going to leave you with 6, and so that means that they're marking up the price by $6. But the question is asking how much did they sell it for? So they bought it for $8 and they're marking it up 6, so we need to add that, and that increases our price up to $14. Number 7, a new pair of sneakers is on sale for $99. They were 10% off the original price. What was the original price? So this is another one where the 99 is representing actually 90% of the price. So since they were 10% off and this is what we paid at the 10% off, if they're 10% off, that means we're paying 90% of the price. And so we're solving for the original price. And when we solve this proportion, we can do 90 times x equals 9,900. Again, this is just the percent proportion. You could also use the percent equation. And when we solve this, we end up figuring out that the original price is $110. Number 8, the school cafeteria buys bottles of water for 75 cents each. They mark up the price 40%. How much did they sell water bottles for? So we need to figure out 40% of 75 cents. That ends up being 30 cents. And so if they're marking up by that much, that means we're adding or combining that 30 cents with the 75 cents. And so that's going to be $1.05 is going to be the selling price there. All right, have a wonderful day.